All right, guys, since I'm not able to be there today, I figured I would finish this example with you through this video, and that should be helpful to get you through the rest of your work for today. All right, so this is going to complete the example we started yesterday in class, and it is, in my opinion, the most challenging example in the packet since it's first, so it should be a good nudge in the right direction for you guys. Okay, so this is the point where we left off yesterday. We had labeled the 5 points that represented maximums and minimums. And then we left off at B, where it's asking us to determine the values of A, B, and D in our model. So our model of the function looks like this. We noted that instead of it saying f of t, it just says D, because D means the depth of the water in the bay. So the first of these values that I always recommend you try to determine is D. D is the easiest for us to figure out because D represents our midline. So hopefully you remember that from the packet that we finished 2 days ago. The midline of the function is just going to split our function in half. So what I'm going to do is I'm going to draw in that midline right now without actually knowing exactly where it's going to be, right? So it looks like it might be somewhere like this. So this is D. But we don't really know exactly where D hits on our f of t axis here, on our D axis. So we've got to figure that out. Well, if it's right in the middle of our function, that means it's going to be half the distance between our maximum points and our minimum points, right? So this distance should be the same as this distance. So what I'm really looking for is the center, or the average, of these two y values. So whenever I try to find D, I'm just going to take my maximum value and add it to my minimum value and divide by 2. It's basically the same thing as determining the mean of two numbers. So if my maximum value is 36 feet and my minimum value is 22 feet, I'm going to add 36 plus 22 and divide by 2, and that's going to give me my average. So I know now that my midline is at 29. So that tells me that, and I don't need you guys to cross it off, but I could replace that with the number 29. I figured out what D is. All right. Next thing I'm going to do is use D to help us find A, because A represents our amplitude. So A is this distance. And also this distance. Remember, it's absolute value, so it's the absolute value of that space there. So to find A, I could go one of two ways. I could take my maximum value and subtract my midline, or I could take my midline and subtract my minimum value, but they both should give me the same exact answer, because if I found the appropriate midline, then those two values should be the same. So A is going to be 7. Now, one thing to note about A, I know that it should be a positive 7 because we've started our function at a maximum like our positive cosine function does. If this function began down here at its minimum value, then I would have to make this a negative 7 to show that this function has been reflected over that midline. All right, and now the last piece that we're going to find is we're going to find what our B value should be. And this one takes a little bit more of a process, because we have a formula that is also available on this worksheet that tells us what the period of a function is. So period is equal to 2 pi over b. But if I don't know period, then I can't find b. We do know the period of the function. We talked about that in class. I know that it takes 12 hours for one full cycle. So that means that the period of the function is 12. So 2 pi divided by b equals 12. And from there, hopefully we don't have too much trouble with this. What I would do is multiply by b on both sides. That would cancel b over here, and then I would have 12b, and then I would divide by 12, and we should start to get to a point where we see this pattern emerge often whenever I'm trying to find the value of a denominator, 2 pi over 12. This switch takes place. I can multiply by b, move it over to this side, then I can divide by 12 to move the 12 over to this side and isolate the b. All I have to do now is simplify that fraction. So now I know that my b value is pi over 6. So what I just figured out is that I'm just going to put it in this space because I've got some room here. D equals, well, I know that my a value now is 7. It is a cosine function. My b value is pi over 6. And I do have my t value here as well. Or the t is the variable, so that stays the same. And then my capital D is 29, so plus 29. So that's the equation of this function. I figured out what a is. A is 7. I figured out what b is. It's pi over 6. So now I have the equation of the function finally. So I'm going to use that equation in C. C says that tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet, which makes sense, right? Because if you're the driver of a tanker boat, that tanker boat has a bottom on it, and that bottom goes underneath the water. So you can't drive a massive boat up a teeny little canal because it's too shallow. You need some depth to the water for that boat to float. So I'm going to make a mark at where 25 would be. 25 would be around here, and I'm going to have that be our water line, or our acceptable water line. So what this says is that if I'm driving the boat, I cannot drive it in this water. That's no good, because that's going to be way too shallow. At those points, the depth of the water is beneath 25. I also can't drive it here. I can only drive this tanker any time that the depth is greater than 25 feet, because it can't be equal to 25 feet either. So I have to set up an equation that allows me to state that the only time that I can drive this boat is when the depth is greater than 25 feet. Well, we have an equation that represents the depth of the water, and it's the one we just created. 7 cosine of pi t over 6. Don't get too thrown by this. This is the same as this. I've just multiplied this pi over 6 by t over 1, moving that t into the numerator just to simplify the expression a little bit, plus 29. I know that that is d. So if I need the depth to be greater than 25 feet, then I need this to be greater than 25 feet, because they're the same thing. So that expression allows me to determine the times when this would be okay. And we don't know how to do this right now, but if I were to solve for t, I would be able to find those times and find all of the intervals where I would be allowed to drive the boat. Because right now I can see very clearly that these are the intervals where I can't, but these would be intervals where I can drive that boat. All right? So hopefully that's helpful in getting you guys thinking about how to manipulate these functions and how they can represent real-world situations. I do need you guys to keep working on this independently, and hopefully this is helpful enough to get you started with that.